Let's see how to enter plates in order to solve a connection between bars with the tools in CYPE Connect. To do this, once the node has been created, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. This way, we access the connection window. In the Model tab, we must specify the operations necessary to define the connection. In this example, adjustment operations have already been carried out on the sections to modify their geometry. Now, we're going to add 3 plates that will allow us to solve the connection between the sections. To do this, we click on the plate option in the top toolbar to enter the first one. First, we define the plate's material. We can use the button on the right to select it from those available in the drop-down menu and then click on Accept. If we now click on the button with the name of the material, we can consult and modify its reference, description and properties, such as modulus of elasticity, Poisson's ratio, coefficient of thermal expansion, unit weight, yield strength and fracture limit. On the right-hand side, if we add the values of the yield strength and fracture limit for each thickness, we can specify the resistance depending on the thickness. In the next section, we define the plate's geometry. We type in the thickness and select the type of plate in the drop-down menu. In this case, it will be rectangular. Therefore, we must specify the X width and the Y width. Now we are going to define the position. To do this, in the Type drop-down menu, we select Connection to define the position of the plate by entering the X, Y and Z coordinates with respect to the centre of the connection. If we need to rotate the plate, we can enter angles about the local X-axis, the local Y-axis and the Z-axis. We can see the entered plate in the 3D view on the right. Next, we are going to enter a second plate, placed on top of the first one. We make a copy of the plate by selecting the operation in the left table and clicking on the copy button at the top. We adjust the geometry of the new plate by checking the X width and Y width values. Then, to define the position, we choose the attached type. This way, we can specify that the plate is attached to another plate, to a section, or to a reference plan. In this case, we select Plate and choose the first plate entered in the drop-down menu. If desired, we can enter displacements in X, Y and Z, as well as an angle about the local Z-axis. At this point, we indicate the location of the plate, which can be on the front face, on the back face, or on both faces, generating 2 plates in the latter case. In this example, we place it on the front face. We continue by entering a third plate that is perpendicular to and on top of the second plate. Again, we make a copy of the plate by selecting the operation in the left table and clicking the copy button at the top. In geometry, we change the type to polygonal. In the table that appears, we click on Add several times and enter the X and Y coordinates of the vertices that form the polygon of the plate. In the Type column, we indicate whether it is a straight segment or a curved segment, in which case we must define the coordinates of the centre of the curve, XC and YC. To help us enter this data, the program displays a help image when clicking on the corresponding button at the top of the table. Then, under Position, we select the perpendicular type. This way, we can indicate that the plate is perpendicular to the second plate, which we choose from the drop-down menu on the right. Finally, we set the displacements in X, Y, and Z to place the plate in the space. We can also enter an angle about the local Y-axis. From this point, we must add the rest of the operations necessary to complete the model of the connection, such as welds and bolts, before being able to carry out its analysis.